Okay, let's take a look at this problem. So it says determine the magnitude of the couple force F so that the resultant couple on this whole crank system is 0. So what do we want to do? Yeah, so if I can first establish the moment produced by this couple, the 150, and then add it to the force or the moment created by this force couple F, set them equal to 0, solve for F. Everybody see the strategy? So in some sense we're going to say the sum of the moments in this problem should be equal to 0. So let's find the moment for the first problem. Since all the distances are given kind of in this system, and you'll notice that this is at 90 degrees, 45, 45, so this is really at a skewed system. I'm going to come over here and look at a x component and a y component for this couple. Might get a little confusing. And then over here, I'll draw it this way. There's my y component. And I'm going to draw my x component here. It looks a little odd, but I don't want to interfere with the other force. So if I'm finding the moment due to this force 150, what would be the x component of that force? Right. So I've got a force of 150 cosine 30, and that gives me the horizontal component. What's the distance between those two? Okay, it's a right triangle, so that means that this distance here would be 8 times the cosine or the sine of 45 would give me this distance, right? And on this side, it would be cosine of 45 times 10. It would be the difference in that. So I'll write that out this way. I'll say it's 10 cosine 45 minus 8, bless you, cosine 45. Okay, I'm confused.
Like you say, like a angle 45 degrees on each side.
Right.
So if you take 180, you have to get 90.
Right, that's correct. This is a 90-degree angle. Oh, I just drew a box like this. And I can find how much it changes in this direction and how much it changes in that direction based upon knowing the hypotenuse. So I know that this height above this edge is 10 sine 45, and on this side it would be 8 sine 45. So the difference should be the vertical. If you guys see it a different way and you get the same answer, I think that's important. Now, those forces, those y components, how are they moving? Counterclockwise, so this is positive. And what about the vertical components? That's going to be the 150 times the sine of 30, right? And they're also creating positive. And what's the distance between these things? Well, it would now be the horizontal piece, right? So it'd be 10 cosine 45 times 8 cosine 45. See that? Sine cosine is the same, so it doesn't really matter. Technically, these should have been the sine, but 45 is 45. Did I see that? I don't know what all that turns out to. That should just be a number. Can somebody compute that for me? Now what do we have to do? The next problem is repeat the process, except we have two components in F. $1.41? Oh, you mean for this piece here? Can you multiply all that out? What'd you get? 212? Anybody else get 212? Alright, so what'd you get? 180? See if we get anybody else get 183. What's going to happen in the second one is that I'm going to have F. Now the vertical is going to be cosine 30. And the distance between those two verticals are now what? If they're half the distance, I'm going to get, it's going to be 5 cosine 45, oops, 45, plus 4 cosine 45. And then the horizontal components will be the sine of 30. And just like before, it'll be the difference in the height. So it'll be 5 sine 45 minus 4 sine 45. So that, and those are both, let's see, those are creating that's negative, and that's negative. They're both creating clockwise rotation. So this should be equal to negative something times F, whatever all that is. So, yeah. So, anybody else get 183 for the first number? Anybody else get 183.71? Alright, we'll just have to wait and see. That sounds good. That's 2. So 183.71. And that should be pound inches. So we're going to get a really small number, I think, here for all that. Oh, that was just for the first part. Say that again?
1,138.
Oh, you got the number. Okay, I guess I'll wait patiently for you to process all this other stuff. Don't forget to add these two. You go ahead and just drop the F out. So whatever all that stuff is. Don't forget this is positive and this is negative. I'll just kind of wait for a second. Remember, the basic idea is just to find the moment from the first set, the moment from the second set, and make sure that they balance. So conceptually, it's straightforward, it's just a geometry issue. There's probably a cleverer way to do the geometry too than the way I did it. Hopefully it'll work out. Anybody else get that? So F should be 1138.31 divided by 5.86. 194 is good enough for me. So this was positive, this was negative. When you add them together, make sure they equal 0, F comes out to be positive. Well, I apologize for that. I thought that was going to be a little easier to calculate.
How is that positive?
Well, one moment is positive, the 1138, and then one moment is negative. And when you add them together, they have to be 0. So F would have to be a positive value for that to happen. If F was negative, it would be minus minus would be positive, and you'd get some huge number. You see that? So I really said 1138.31. Well, plus would just be minus F times 5.86 equals 0. And that. Okay. All right.